squares here. Basically, guys, every piece of geometry on the SAT will boil down to circles, triangles, and squares, some combination thereof. All right, so we're going to go over a few points, and we're going to practice a few questions here. In general, just best practices, things you must do. You've got to mark your figures up to the maximum possible extent. This means that when you have a geometric figure, you've got to mark the sides and the angles. Do not forget about the angles. In order to demonstrate what I mean here and how important it is, we're going to take a look at this example on the right, which is this circle. And it says a lot of different stuff in the problem, but there are things we should mark before we even start the problem. Before we even read anything about the fancy ratios and angles, once we know that O is the center, what should we be marking? And it looks like maybe Brandon has an idea. I see him typing. So Brandon, you have an idea of what we should mark? Or maybe not, maybe Tiala. Radius, okay, very good. So what is the radius? Well, a radius is anything that goes from the center to the circumference, guys. This and this are equal. Before we even start reading the problem, maybe we want to confirm that the center is O, because I guess it might not be in some certain circumstance, but those two radii are equal. And after that, there is even more that we can mark up. So Tiala, after we mark that AO and OB are the same, what should we be marking as well? There's something that follows directly from that. Okay, yep, so A is congruent to B. All right, both angles have to be congruent because basically what we're dealing with here is, I'm going to draw the triangle outside. We've got triangle AOB, all right? And if we know that triangle AOB has two equal sides, that's an isosceles triangle, it must have equal angles, okay? Bottom line. So that's the stuff that has to be marked even before we run with a problem, okay? So we're going to return to that problem maybe in a bit, but I just want to emphasize the second big point: don't make amateur mistakes. So what's an example of an amateur mistake? Here's a good one. If you're given the area of a square, don't divide by 4 to get the length of the sides. This is a really, really common mistake. I see it all the time, and it really breaks my heart. So for example, if you've got a square, so maybe it looks like this, just finish drawing it here, okay, and they tell you that the area of this thing is 50, all right? So the area of the square is 50. Do not do 50 divided by 4 to get the side lengths. What do we have to do? Well, for the area of a square, we should keep in mind, we should write the formula area is equal to side squared. Not length times width, because that implies that the length and the width are two different measurements. But for a square, again, marking up as we should be, we know that all 4 sides are equal. So we can just designate each side as S or X or N, whatever you want, and S times S is the area, side squared. So really, the sides here should be square root of 50, right? Because we know that area would be 50, and that would be equal to S squared. And to solve for both sides, we would have to take the square root, okay, to solve for S. So don't divide by 4 and get, for example, that each side is 12.5, because we're not doing perimeter here, okay? Another thing to keep in mind, you should not forget basic geometry rules. So for example, the hypotenuse is always the longest side in right triangles. Another example, the inequality rule of triangles. Folks, I can't tell you how many times I see this rule put into play as a hard question rule toward the end of math sections. This is the easiest thing in the world, but so many students forget it. So I want to take a look. Here's your hard math pro tip. We're going to talk about a very, very useful techniques for this sort of thing. So when asked about the possible triangle side lengths in a given triangle, do this. So let's say you get a question that sounds like, I have a triangle and two of its sides are 6 and 10. What are all possible lengths of the third side? Well, we have this in X, which I've designated as the third side, surrounded by two less than symbols. That's what you're going to write on your paper. You're going to draw yourself the triangle, label the sides up, write the X, and then write the less than signs around it. You add the sides you have, you put the sum over here, 16. You subtract them, you put the difference over here, that's 4. You've now found the possible range of side lengths for your third side. It's got to be between 4 and 16. It cannot equal either of those numbers. And once again, this shows up constantly as a hard problem on the SAT. Hard problem concept, easiest thing in the world if you do it like this. So can I get a yes from everyone if everyone's with me? You guys understand what I'm talking about? Great. Excellent. Okay. So, well, Brandon, just keep in mind when you have a triangle, so I'll draw out another triangle, and this will be actually a useful exercise for everyone else. Let's say you've got another triangle. I'll draw one out that looks kind of like this, okay? And this is not necessarily a right triangle, not necessarily any type of triangle. But let's suppose you get that this is 4 and this is 5, and they ask you for the possible side lengths of this third side. Jessica, you asked a good question. This is that trick. And we'll talk about that in a second. But this is basically that two sides have to add up to longer than the third. So Jessica, this is the rule you're thinking of. But I just made it easier by systematizing it. Okay. So guys, this is basically it. If I want to know the possible lengths for that third side, I write my X there. I'll put less than signs around it. What am I going to do to find my possible lengths? I'm going to add together the side lengths of the sides I do have. So 4 plus 5, that's 9. I'm going to subtract them. 5 minus 4 is 1. Now I know that my third side needs to be between 1 and 9. That's it. So if they have an answer that says, okay, it could be 7, yeah, it could be 7. And Allie, yes, it works for any type of triangle, except for it'll work for a right triangle as well, but keep in mind that if they give you a right triangle, keep this in mind, that the hypotenuse is always the longest side. So that's really important for you to remember, okay? But every single triangle in existence will subscribe to this rule, okay? Yeah, so it is great, Josephine. I'm glad you think so. I hope everyone else does too, because it's such an easy trick, but this comes up all the time. The 9 and the 1 are exclusive, Anthony. You cannot, notice I don't have equal to signs over here. So those are not equal to signs, that's less than. So X can't equal 1, it can't equal 9, but it could equal, for example, like 1.001. If it says it has to be an integer, the smallest it could be in this case is like 2, and the largest it could be is 8. All right, if it has to be an integer. Nice question. Okay. So now what I'd like everyone to do, I'm going to clear some of this crud. And by the way, guys, this whole thing is being recorded. So in case you missed something or you don't understand something I did, you can always go back to the recording and watch again. You'll have the recording emailed to you. But also keep in mind that you can email me as well. I want to finish this problem on the right. I want everyone to take a shot at it. I'm going to give you about a minute to try to solve it, and then I'm going to open a poll so that you guys can submit your answers, and we'll see if you guys get it. All right, and while you guys are working on that, I'll answer Brandon's question. If you are, so Brandon, just, I can't help myself. Your should be Y-O-U apostrophe R-E. If you are really bad at geometry, is this part of the SAT? Don't worry, I just want you to know the correct form. No apology needed. So is this part of the SAT going to hurt you? Remember, this is the hardest of the hard stuff. A lot of these simple concepts will translate to easier concepts. So this would be an example of the worst it could get. So if you guys are working on this now and you're like, I don't understand anything, it's okay, but don't forget everything we do because a lot of it translates to even simpler stuff. So not knowing this very problem is not going to